Okay, related rates problem number 1. I'm so glad to be getting into these because they're fun. We can depict it. You know, it's not just numbers and letters anymore. We can draw pictures. But before you do, make sure you watch the explainer video because I'm going to assume that you did. It's only a couple minutes long. I'll put a link in the description. Watch the explainer video first. Now, let's begin. If a snowball melts, so a snowball, I don't know about you, but is usually considered to be spherical. We'll put a little thing on here to make it look a little more like a ball. It's melting so that its surface area is decreasing. So let's say it's going to change in radius like this, right? It was this big and now it's going to be only this big. And what would we even, at a rate of 1 square centimeter per minute? So let's call that like the change in surface area over the change in time equals -1 centimeter squared per minute. Find the rate at which the diameter decreases when the diameter is 10. Okay, so how are we going to do that? Well, we know that the surface area of a sphere is 4 pi r squared. And if you don't, you can Google the formula for surface area of a sphere, but you should know it. It's also the derivative of volume. And then we give ourselves the benefit of the doubt with diameter, so we know that the r is equal to 5. Everything's in centimeters here. Did I miss any of the given data? I think that's all we're given. Okay, so what can we do? They gave us a ds dt, but there's no t here. We have a radius. Yeah? We can take a ds dr, right? We can say ds dr equals 8 pi r. All I did was take the derivative right there, yeah? But I can also say ds dt is equal to ds dr, and then try to fill in what would work here, which would be dr, so that these would cancel. Yes, that'd be good, dr dt. I don't know if you can see that, but if these cancel, then these are equal, right? So this should work, and we have some of this. We know ds dr, we'll plug that right in there. So let's say it like this. -1 for ds dt equals 8 pi r for ds dr times dr dt. I love it. And you know what else? I'm pretty sure they gave us the radius is 5, so 5 times 8 is 40, so we'll do -1 over 40 pi equals dr dt. Is that what they asked? Find the rate at which the diameter decreases. That is not what we found, is it? We found the rate at which the radius decreases. So if we want to relate it to the diameter, then we would have to say like the change in diameter over the change in time is going to be twice the change in radius over the change in time, right? Because if I have a circle, whatever rate at which the radius is changing here, it's also happening on this side here. So I think it's just 2 times that. So that would be, we'll call it dd dt. That's hard to say. -1 over 20 pi, and just multiplied it by 2. And then what is that? Centimeters per second? Minute? Whatever it is. Doesn't matter. I think it's minutes. Call it per minute. That's our answer. And the trick here was what? The trick was to look up the related rate in between, which was this dr here, to find this. So as you're comparing surface area, time, and radius, we have 3 different variables that we're playing with between on the derivative side. All you have to do is keep them written down and organize them appropriately, and you won't get lost. You'll be fine.